Hello, we're here to learn our last way of how to factor. We've already learned greatest common factor. We've already learned difference of squares. Our very last way that we're going to learn, in Algebra 1 anyway, is called sum product. And there are two things that you have to know about sum product. The first thing you need to know is that, like difference of squares, sum product can only be used after you've already thought about greatest common factor. The second thing you need to know is that sum product is used to factor a trinomial into two smaller binomials. So what all of our problems are going to look like is x squared plus bx plus c. Now, of course, the b and the c are going to be numbers. They're not going to be variables. But we're going to factor this trinomial into two smaller binomials. And these binomials are always going to start out with the letter x. And that is because I need to go x times x to make this x squared. But now the other two spots are going to be two numbers. Let's call them capital B and capital C. So there's going to be two numbers here, and they're not the same numbers that are up here in the original problem. They're going to be different numbers. But what needs to be special about these numbers is that when I take these two numbers and I add them together, they have to create the middle term. Also, when I take these two numbers and I multiply them together, they have to create the last term. So let's see what this looks like. Problem number 1 says m squared plus 2m minus 24. I should always think about greatest common factor first. So if I think about greatest common factor first, well, a 1, a 2, and a negative 24 have nothing in common. So there's no GCF. But I do have a trinomial. So I'm going to see if I can use sum product to break this down and create two binomials. Now, the beginning of this binomial always has to be the variable. So I'm going to put an m here and an m here. And again, that's because when I go m times m, that's how I get this m squared. Now I have to figure out what two numbers am I going to put in this back area. And remember, these two numbers, when I add them together, have to make positive 2. And when I multiply them together, have to make negative 24. So I have to figure out what numbers can do that. Now, the easiest way for me to do that is I start by looking at the negative 24. And I list all of the factors to the number 24. So I know it could be 1 times 24, it could be 2 times 12, 3 times 8, or 4 times 6. So I have 4 possible pairings of numbers that would multiply to 24. Now all I have to do is take these 4 pairings and try and figure out which one of these is going to add to make the 2 in the middle. Well, let's think about 1 and 24 first. Well, those add or subtract to make 2. No, they will not. What about 2 and 12? Nope. 3 and 8? Nope. But what about 4 and 6? Well, 4 plus 6 gives me 10. But 6 minus 4 could give me a positive 2. So those are the two numbers that I'm going to use. I'm going to use a positive 6 and then a negative 4 so that I get 6 minus 4. But now I need to double check. Do these two numbers add to make the middle term? Well, 6 plus negative 4, yeah, that makes 2. Do these two numbers multiply to make the last term? 6 times negative 4 does make 24, negative 24. So this would be my factored answer, m plus 6 times m minus 4. Let's look at number 2. First, think about GCF. Well, all 3 of these terms, I can factor 2 out. So I have 2, and then k squared plus 11k plus 30. Now, inside my parentheses, again, I have a trinomial. So I'm going to see if I can use sum product to break that down. So I'm going to keep the 2 in the front, but then I'm going to get my parentheses ready to make my binomials. I'm putting a k here and a k here. And now I have to figure out, okay, what two numbers can add up to make a positive 11, but they're going to multiply to make 30. How I like to do that is make a list of what are all the factors of 30. Well, 30 is 1 times 30, or 2 times 15, or 3 times 10, or 5 times 6. Now I have to look at these. Which pair can either add or subtract to make 11? Well, 5 and 6. If I go 5 plus 6, that makes 11. So a positive 5 plus a positive 6 will make 11. Now before I finish, I'm going to double check this. Does 5 plus 6 make 11? Yep. Does a positive 5 times a positive 6 make a positive 30? Yes, it does. So that would be my final factored answer. Number 3. I'm not going to go all the way through the steps quite as slow as I went through the last ones, but I should always think about GCF first. So looking at these three terms, they all have the number 5 in common, as well as they all have an x in common. So 5x is going to be my GCF, which would leave me with x squared minus 6x plus 8. Now, because there's a trinomial in my parentheses, I'm going to try some product. So my 5x stays out front. I'm getting my parentheses ready to do my binomial times binomial, putting x times x in the beginning. And remember, I have to find two numbers that are going to add up to the middle term and multiply to the last term. So make a list of all the factors of 8. So 1 times 8 or 2 times 4. That was a short list. Now I have to figure out what pairs are going to add up or subtract to make a negative 6. Well, a 2 and a 4. I could make that negative 6. Like if I had a negative 2 and a negative 4, that would get me to negative 6. So let's double check. Is negative 2 plus negative 4 negative 6? Yes. Is negative 2 times a negative 4 a positive 8? Yeah, it is. So there's my final factored answer. Let's look at number 4. Try GCF first. Anything they have in common? Well, I have a 1, a 4, and an 11. No GCF. So now I'm going to try some product. So I'm filling up the beginning with g's because that's my variable. Now I have to find two numbers that are going to add up to be 4 and multiply to be 11. Well, let's make a list of all the factors of 11. 1 times 11. That's all. Is 1 plus 11 going to make 4? No. Is 1 minus 11 going to make 4? Nope. So this situation I actually can't do. I can't factor this because there is no way that I can add up to 4 and multiply to 11 at the same time. So this problem I cannot do. Question number 5. Try GCF first. There isn't one. Now I have to look for my sum product. So I have x and x. I need two numbers that are going to add up to negative 1, but multiply to negative 90. That ends up being negative 10 plus 9. And that would be my final answer. Number 6, try GCF first. When I look at these three terms, I see they all have a 4 in common, and they all have an a squared in common. So that would leave me with 1a squared minus 1a minus 2. Now if I go from here and try some product, I would have an a and an a. And I need two numbers. I need one that's going to add up to negative 1, but multiply to be negative 2. Well, that would be a negative 2 and a positive 1. And there's my final factored answer.